Hello, everyone. Hope you're doing well wherever you are. I'm Dave Rubenstein, Editor-in-Chief of SD Times, and I'd like to welcome you to today's program, Scared Serverless? Don't be. We'll look at the particulars of serverless applications built with microservices and how, despite the stateless nature of serverless and the challenges of keeping an eye on so many moving parts in the new architecture, effective monitoring can make serverless a much scary proposition. Beyond that, you can read our article on monitoring microservices applications in the upcoming June 1st issue of SD Times magazine, as well as on sdtimes.com. It's the final installment of our three-part deeper look examining application monitoring, which began in the April issue. Parts 1 and 2 are on the website now. Before we get started, I have a couple of brief housekeeping announcements. First, today's webinar will be followed by a live Q&A, so you can ask your question at any time during the program, going to your control panel, clicking on the questions tab, writing it, and we'll get to as many as time allows. Secondly, today's webinar is going to be recorded and available on demand on the sdtimes.com website beginning tomorrow. So joining me today, as you can see on either side, are two experts from application monitoring company Instana. Drew Flowers, who's the solutions architect there, and Chris Farrell, who is technical evangelist and APM strategist. And now to get us started, here's Chris.
You're muted, Chris.
You're muted, Chris.
I knew I was going to do that. Thanks, David, and thanks everyone for coming today. Really appreciate you being here. Quite excited to talk to you about serverless and why you shouldn't be scared of serverless, but along the way, we'll talk about some things that you maybe want to be scared of when you're doing serverless. So as David said, my name is Chris Farrell. I've been in the APM space for 20 years now. I was an original product manager of one of the original APM solutions, so I've had a lot of experience here. And I'm going to take you through some concepts and ideas of serverless architecture, serverless monitoring, serverless deployment, and then Drew's going to take you through a demo of actually monitoring some serverless code and applications. So I thought it would be good to talk at first about, let's see if we can get this to actually work. I thought it would be good. Well, let's just do it this way. I thought it'd be good to first talk about the first time I heard about serverless. And I got that feeling you get when you walk down on Christmas morning and you see that present that you weren't really expecting. And no, I don't mean the Ralphie Bunny suit. I mean, when you walk down and all of a sudden there's a pool table in the room. I'm going to try to get this going. Otherwise, it just isn't going to work real well. Bear with us. Sorry about this. Not the right thing to say.
You're muted again, Chris.
Thanks. I guess we won't have any funny animations today. I was at a tech conference. I was in a bus, one of the shuttle buses riding back. It was about 5 years ago. And I heard a chief architect from one of our customers talking about this new technology they had just been talking about called Lambda. And they were telling one of the other programmers about it on the bus. And the hairs of my arms started to stand up. And the person I was with is like, what's going on? And just the concept of what he was describing to me of your code's there, but it's not there until you need it. And then it runs and then it's gone again. And it just made me so pumped up and excited from an operations perspective, from an efficiency perspective. I got so excited about where are we going with our technology. And there's something kind of unique and special about serverless when it comes to operationally, what makes it different from other virtualization technologies, other cloud deployment technologies, other advancements in IT operations. And I really got to think about it from the perspective of a metaphor that I like to tell people when I'm trying to describe virtualization to them. And I talk about water heaters, and I say, we'll start with the idea that every place you have a sink in your house or a source of water, you have your own unique water heater. And that water heater delivers hot water only for that sink, and it has to have the maximum amount of water to deliver for that need of that sink. And then go through, well, what if you had one water heater for the whole house? Oh, well, that's private cloud. What if you had one water heater for the whole street? Oh, that's public cloud and shared cloud and so on and so on. And I get to the end and I talk about containers, and I talk about them as if they were tankless water heaters, because they're like, well, they're ready to go, but they're much smaller pieces and they really only operate when you need them. There's a physical aspect to it that matches up. And then you get to serverless. And someone asked me once, well, what's serverless like? And I said, well, serverless is like, I need hot water in my pot. So I just stick the pot out and hot water magically appears out of the air, goes in the pot, and I pull the pot back and it disappears. And that's just the beautiful magic of serverless. And so that's when we start thinking about, what can we do with this stuff? Why is this so cool, and what can we do with it? So I wanted to start with, why should you go serverless? And I could tell you the reasons that I think you should go serverless, but I think more importantly is to bring in what I like to call web wisdom. So I went out and did a consensus view of a couple of different blog posts from operations companies, from SD Times, shout out Dave, and some other places where people are talking about, why should you go serverless? And I think we all understand that the first aspect of serverless that we get excited about is that there's less maintenance and lower costs. And that is actually two separate things. You have less things to maintain because you don't have to bounce up a server. You don't even have to spin up a container. You literally just get ready to go on your platform, you deploy your code, and you go when it needs to go. But because of that, your costs can be, I'm going to put that in quotes, can be lower. Your compute costs for whatever cloud platform you're running on can be lower based on that. You eliminate the entire need for capacity planning and capacity management. There's no servers to spec, there's no servers to manage, there's no capacity to manage. You will simply run it when you need it. And then several sites talked about stateless being a benefit of serverless. And having stateless code is a benefit. It's not that it isn't a benefit, but you'll notice stateless ends up on the other side of this, in the dark side of serverless, because let's face it, most of us are writing and deploying stateless, stateful applications and stateful services. So to have this type of code or type of service that's actually running stateless, that can create a problem as we start to implement serverless functions with non-serverless functions. I think it's important to talk about, you can spawn serverless functions just like you do any other type of method or service, and in a synchronous manner, but also that you can trigger them through for asynchronous types of process handling ideals. So if you think about a complex business process, you can actually trigger some middleware or some process translation function that you run in a serverless function. Now that's actually a pretty good test case and use case for production use of serverless code. The other interesting aspect of serverless that makes sense is when you're prototyping, both in development and also in early QA, maybe even early production, as you try to spin up and see what's going on and you're doing your prototyping. So these are all the reasons why to go serverless. Now I'm going to tell you a little secret about new technology. And this is a secret that developers probably have never even worried about before. As a developer coming up the ranks, I never worried about things like this before. But here's the key to new technologies, especially new application technologies. Cool new technology being introduced makes developers very happy. It's new stuff we get to play with. It's going to make things easier to architect and program. It consolidates things. It creates black boxes. There's all kinds of different stuff that each step of new technology, especially application platform technologies, give us as developers that are make us very happy. Every single one of those makes IT ops a little bit unhappier. And you can literally go back to client server introduction 25, 30 years ago. But I like to start that world or that concept even 20 years ago when J2EE started to become the big prevalent application platform in enterprises. And as technologies advanced around that particular set of code and app servers, and then other languages and other code for enterprise integration, every time a new technology is introduced, what happened? Problems with visibility, problems with observability, problems with performance, problems with new platforms. IT ops suffers when developers get happier. It's just the way that things are or have been up to now. Of course, the world of microservices makes all that change just a little bit, but this happiness curve, it's still kind of out there a little bit. So one of the questions that I wanted to answer today, or at least get people thinking about, is should you go serverless given this happiness factor for developers and unhappiness for production? So first of all, it's absolutely extremely useful for prototype development, whether you're a single developer, a team of developers, a few small teams of developers trying to quickly spin up an application prototype, either in your system test environment or for that first scaled production test environment. Spinning up a prototype is a great use of serverless. You have no admin overhead, you have extremely low cost because you're only paying for compute power, and it's also easier and quicker to update because all the pieces aren't necessarily connected from a code deployment perspective, but rather from an operational perspective instead. The nice thing about prototyping production is that not only does it save all those costs for developers, but it also saves those costs for operations staff. So that's a little nice bonus. And then the big question is, do you stay serverless as you go into mainstream production? So the benefits that we just talked about, they don't go away. But you do have a couple of problems that are introduced when you go mainstream production. The first is, how are you going to monitor performance? If you're not monitoring performance of your production applications today, then you're either loving danger, and I've got some high-end bridges you can bungee jump off of without bungee cords, or your apps just aren't that critical. But I've always been under the my viewpoint has always been that every app is critical to somebody, so every app should be monitored. But let me, I want to really dig in on this. Just because these are problems that can occur doesn't mean you shouldn't use serverless in production. It does mean you should be careful and considerate about what you're going to use as a serverless function versus a stateful function, how you're going to tie it in with your non-serverless entities and services, how you're going to monitor performance, and this is a big part, because this is a big part of APM. It's called application performance monitoring, but a big value proposition of APM is to help troubleshoot problems when they occur. So troubleshooting becomes actually one of the more difficult aspects of deploying serverless in production. Oh, look at that, I thought I was presenting. So let's talk about some of the reasons not to go serverless. We just talked about one, observability is more difficult. Two, there's a thing called a cold start. We haven't talked about it yet. A cold start is essentially if you're truly simply running your functions exactly as they're needed and only when they're needed, then there's a little overhead that's required to start up every serverless function. It's the what do you actually need to get ready and set up and run and deploy. There is a set of memory, there is a set of IO that's going to be needed. That's called the cold start. And if you are always implementing, always executing your serverless functions and then destroying them, letting them go away, that means you've got a cold start on every call. Now, depending on what resources you need And depending on how big your serverless function is, the cold starts can add different latency and different overhead at different for different types of service of functions. So you have to be cognizant of that, and you have to look out for that. It's not a problem, but it's something that you have to think about, architect for, and deal with, is how do you add state into your application as you run several number of stateless objects in your serverless functions throughout. And then the last piece is, because of the way that serverless is deployed, every cloud having its own type of serverless platform, you can get a heavy reliance on specific vendor ecosystems. In other words, what we're all spending all of our efforts to avoid, vendor lock-in, yep, if you're going serverless, then you are moving towards vendor lock-in. It's not true vendor lock-in. I mean, your code is your code, but you're running it on platforms that are tied specifically to cloud vendors. And the reason I've got the seesaw here is because those two problems of observability and vendor lock-in, they're tied together, because up till now, or up till very recently, the only way you could really get observability or performance, or one of the two ways, was to use the vendor's APIs. So we're going to talk about that, but that, of course, can, if you start monitoring based on vendor APIs as your number one source of data, then you are buying into some vendor lock-in. And that's not necessarily a showstopper, but it is something that as organizations are trying to avoid these days. So all of these things really lead me to the dark side of serverless. This is the stuff you should be scared of, but it doesn't mean you should be up at night thinking about it and worried about it, but it's stuff that you should consider and worry. So first, serverless is difficult to debug. Distributed complexity complicates management. Let me talk about that in a broader sense for a second. The more complex your architecture is, the more difficult it is for your ops teams to A, understand what needs to be monitored, B, understand how to monitor it, and C, understand what that monitoring data actually means and interpret it. So you're in a distributed system already. Now you throw in this element of, well, we've got some services that are going to appear for 240 milliseconds, and then they're going to disappear. And oh, by the way, you need to figure that out, know when they run, know what the performance was, compare it to performance of other things like it, but not actually that, because that only appeared and then went away. So it complicates management in general. And then in many enterprise applications, they're stateful, as we've been talking about. The state has to come from somewhere. So we talked about cold starts. Don't forget them. I've got my note there. Don't forget cold starts. But in addition to cold starts, you have this idea that if you're running a stateful application and you're using serverless functions, that means at some point part of the serverless function has to go get whatever aspect of the state they need or it needs in order to perform. Now, I'd love to say that I came up with these. This is actually from a blog post from our lead serverless product manager, Michela Mangiopi, and you can actually read that on our website if you want, and it's called Observability Best Practices for Lambda. Now let's talk about transition a little bit. Drew's going to show you monitoring. I want to set this up and talk about how we can go get the data we need to monitor serverless functions. And by we, I don't mean Instana. I mean we, IT operations, IT development, dev and ops together, SREs. Where are we going to get the information that we need? And the first part of these, as I was talking about earlier, are vendor-specific metrics. So I think almost everyone's familiar with Lambda X-ray. This gives a set of information that you can use APIs and extract and get different pieces of data. There are, of course, ways to get performance metrics from other serverless function or function as a service pieces. So Microsoft Azure has something called Application Insights that has some APIs that you can use. Google has Google Cloud Functions These all provide a little bit of data as you try to get information about the serverless functions running on them. Of course, you're limited to only the metrics that they decide they're going to provide you. You are definitely tying into vendor lock-in. If they trace, they are literally just tracing what's going on in that piece of code. And then finally, you're going to need a tool to collect, report, do historical storage, etc. So unless you just want literally just a snapshot in time, these things have a limited use case. Doesn't mean they're completely useless. And by the way, as a data source, they're interesting to include with other pieces of data. Hint, hint. We'll be talking about that later. The second way that you can go about getting some performance data is to instrument code yourself. So all kinds of different options exist. Prometheus is probably the one that most people have heard of or are using. Open Tracing and Jaeger, good examples of tracing data. Prometheus is a good example of monitoring metrics or latency data. It's good. These are open standards. Most of them are open standards. Most of them are open source. Most of them are designed to avoid vendor lock-in. These are all good things. Now, if you also have standardized on these things for your non-serverless services, then it's something that you can standardize across both. If you haven't, you're literally just going to be adding them in. But even if you have standardized with an open source instrumentation for non-serverless functions, there's some kind of nuances to serverless that gets in the way, makes it not quite as useful. So the first thing is, of course, it takes developer resource and time to write the monitoring code and insert it into their actual code. But beyond that, because serverless functions tend to be less code, we're seeing at our customers that sometimes when people are running serverless, their manual instrumentation can be upwards of 15, even 20% of the actual running code. So you're hurting yourself from an overhead perspective in your CPU. You're hurting yourself in overhead perspective of bandwidth. You're hurting yourself in perspective of compute time, because the whole idea of using serverless is to be more cost efficient. And of course, you're hurting yourself in time, your developers. So this isn't exactly an optimal way of getting data, but it is a way that a lot of people have done, and they've dealt with this 15 to 20% adder as they can see fit. So of course, there's also the old school APM solutions. And this could be either Gen 1 or Gen 2, but these are all based on old instrumentation technology. And that technology, their on-the-fly instrumentation, doesn't work real well in a serverless environment. So the way that they have you do it is you take your code that you've written, then you go instrument it with their stuff. So it's similar to you deploying your own instrumentation to code. You're just going to use their instrumenter, so you don't have to write it yourself. So you save that time, but you still have those same, you're introducing extra overhead, you're introducing additional problems there. It's a suboptimal starting point, to be honest, to make everyone that has code go run it through an instrumenter and come out with something else to deploy instead. The other interesting thing is that since every function is unique, you're not really able to adjust on the fly to what you need to understand. And then the final piece is that every time you want to do an update, you have to re-instrument it. So some of those things actually are also problems when you move into the tracing side of their world. So especially in microservices, and then especially in serverless microservices, sampling of traces becomes problematic. And I could probably spend an hour and a half talking about why statistically and scientifically tracing has problems in microservices and tracing has problems in serverless. But I rather than do that, it's just really a lot easier to say every single request is unique, every single function is unique. if we're really running in a stateless, if we're really running stateless code and every piece of function is going to pop up, that means every single request has a unique service function that served it. So sampling the request at 320 does not help us understand what happened at 321 when something came in and took a completely different path. This problem is actually exacerbated by the asynchronous, because you have no idea when things are going to come in, or what caused them to trigger, or what the request actually was. So let's move on to some best practices. First, let me start by saying, I'm going to move this over here. Serverless doesn't run as an island. You know, even if you were to write your entire application in serverless, each individual function can't operate on its own. Otherwise, you're not really running serverless services. You're running a big giant monolith, and that's not the point. So serverless doesn't run as an island. So it's best not to manage different serverless functions as an island or in a vacuum, or pick whatever metaphor you would like. So I put in here a little sample screenshot. You'll actually see this in Drew's presentation, or in Drew's demo. The idea of managing any kind of microservices application is, first, to be able to find all your services, second, be able to map all the services, and third, understand the interactions between them all. And that's true whether they're stateful, permanent, or serverless functions. So let's talk about some monitoring and tracing best practices. So best practices for managing applications: track the dependencies, adjust dependency maps in real time, and monitor and trace automatically. This just helps. By the way, that doesn't mean that you can't support your manual instrumentation that you do have. Like I said, we have lots of customers that's their strategy, is to have some of that. We want to include that in things that we do, and that's something that you should be looking at as part of whatever tool you have. But you want to put as much automation as you can when you're dealing with the very tiny footprint of serverless functions. And then best practices for tracing: you should trace every call, and you should trace automatically, and you should trace throughout the whole system, not just the requests in and out of your serverless functions. So thank you for bearing with me on my PowerPoint's inability to actually run a screen show today. I'm going to turn this over to Drew now for a demo, and I'll remind everyone to go ahead and ask any questions that you want right now, and feel free. We're going to be happy to answer them.
Awesome. Thanks, Chris. And good morning, afternoon, or evening, depending on where you're joining us at in the world. My name is Drew. I'm one of the solution architects here at Instana, and I want to go ahead and show you today how we try to tackle some of these problems that Chris just articulated over the course of his presentation. Because as he said, serverless presents a lot of different challenges, whether it's trying to understand what exactly the operation of this service is, to even just getting tracing into it to begin with, whether you want to use manual instrumentation or even try our path, which utilizes our auto tracer. So how does it work? Let's take a peek. Well, this is the Instana console. You know, as you can see from what we present in the very first landing page, we are trying to present not just application performance metrics through tracing, but also website EUM functionality, which does function in our Lambda system, as well as platform as a service and infrastructure monitoring. Now, all of these things are really easy to set up. We've designed this to be a fairly automated system. So let's take a minute and focus specifically on Lambda, as that's really our serverless framework at this point in time. Now today, obviously, we want to suggest you use our native tracing because end-to-end visibility is a challenge, and we do provide a lot of tools that make analysis of your application very simple. How we set this up is just as easy as utilizing the tool. It does require two prerequisites. Basically, you're going to install our auto tracer as a layer, as you see here in our documentation, and we're also going to need to utilize what is called the AWS collector agent. Now, to install this particular agent is actually a very straightforward process, as we do give you all the different development tools for our agent right here. So if we're trying to install that AWS sensor, we simply pick AWS, and this provides you all the context to install it as you need. You can see the mode flag here that flags this as an AWS agent. Now, this is installed on an EC2 system running inside of your AWS. We do not want you providing us with public or private keys to any of your accounts. We feel this is a much more secure stance to take. Now, once that agent is set up, what it's going to do is begin pulling CloudWatch for all of the information that we can attempt to extract. This is going to be all the entity info from the actual Lambda itself, as you see here, how many of these are running, how many replicas of them exist, and what metrics can we populate for each one of these directly out of CloudWatch. So you'll understand your throttles, your errors, your invocations, and even dead letter errors. This is all presented for you. But as Chris mentioned in his early portion of the presentation, metrics only tell you one piece of the tale. We need to make sure that we can get some tracing in here so that you understand how this Lambda is interacting with your environment. And the cool thing about how Instana functions is that we treat your Lambda as a component of your environment. Because behind the scenes, something that you're never really going to interact with on a day-to-day basis is this. This is what we refer to as our dynamic graph. And in essence, this is how we track and catalog all of the entities that exist in your ecosystem, whether it's a Kubernetes worker node or indeed even a Lambda function. So as CloudWatch tells us what Lambdas exist within your AWS, we're cataloging these as a component of this dynamic graph. And then from here, we can also instantiate the tracing. Once you get that layer set up, we're going to be able to provide you autonomous tracing that requires zero code modifications. Going back to our documentation for a second, you can see that all we need to do here is save the Lambda function and make sure that the layer is applied. Now, if you do want to go down the process of using manual wrapping, we do provide you the ability to do that, and indeed even the context that you need to set up in order to facilitate that. However, as Chris mentioned in his early portion, a lot of these things, whenever you require long code modifications like this, is just yielding vendor lock-in. And that's actually something that, regardless of the fact we're a commercial APM product, we actually strive to avoid. Now, once that layer is set up, that Lambda is going to become a component of your overall application. In fact, if I look at my dependency map for my robot shop here, and this is running inside of GKE in Google Cloud and utilizing a Lambda function inside of Amazon, you can see my Lambda right here on my dependency map, the ratings reward service. He's being communicated to via discount and catalog, which are simple Java-based services running inside of my Kubernetes environment. When I dive into the actual service layer here, we get all the metrics that are pertaining to this specific microservice, what endpoints are being interacted with, what's our latency and processing time, where are we spending time with these requests, and what is our aggregated error rate. We can even map out the flow interactions of what services touch this particular Lambda function, and we can take it a deeper layer by showing you the endpoints underneath that, and indeed mapping out all the interactions for the specific endpoints from your front-end services all the way down to your databases. So we can help you understand exactly how this Lambda is a component of your application, how it's interacting with non-serverless services, if you happen to have any, and indeed give you all the metrics that you expect to see from an APM product so you can understand and course correct whenever optimizations are required. Now, application perspectives, which is what you're looking at here, is not the only mechanism to interact with Lambdas. A very common use case is utilizing Lambdas to serve out front-end objects of your website. So to that end, we want to make sure that we catalog what's going on the customer side as well. So using our EUM monitoring system, which is of course included in all of our APM licensing, all you have to do is plug in a simple piece of JavaScript, just like you would expect any EUM to do. Once this is done, we're of course going to catalog exactly what your customer browser sessions are experiencing, from JavaScript errors, load times, pages being interacted with, and even a geographical distribution of where people are talking to your site from. But the key here is that when I'm analyzing a page load, for example, and I'm trying to understand how my Lambda is interacting with this particular user, we can actually correlate your front-end EUM transactions directly to those back-end Lambda traces as well, allowing you to follow these user journeys from front to back. Now, this is done very simply by way of a header injected through that JavaScript that I showed you, and of course, some interactions with the trace IDs on the back end. But when you look at the different assets that are being called out, you can see this little button here that simply says View Backend Trace. Now, when you use this, it obviously takes you directly into that backend request. Here we can see exactly what was called by the Lambda. In this case, it was one simple request of a GetApp US endpoint. We can see how it was served out and how long it took. Any other assets that are being called, maybe by other Lambda functions, we can also trace back as well. So you're going to have full context and correlation between how your users, your backend services, and your Lambdas are all interacting with each other. And when we pair this alongside the CloudWatch data that's being exposed by Amazon that we're collecting by virtue of that AWS agent I mentioned, you're going to understand everything we possibly can about these serverless systems. And when you have this level of understanding, it'll help you drive deeper and better optimizations for your customers. And that's truly our goal here with Instana, is trying to make sure that everything you utilize, whether it's a serverless Lambda function to Kubernetes or Pivotal Cloud Foundry systems, that we have this all covered appropriately and that you understand from a second-to-second moment what these systems are doing. So of course, if you like the things that you've seen here today from our serverless tracing, or maybe you want to deep dive what we can provide for Kubernetes, please do check us out at www.instana.com, where we have free trials available for 2 weeks, or you can request a demo where a solution architect like myself will guide you through the full breadth of our product. And with that, Chris, I'm going to hand it back to you.
Thanks, Drew. David, I'm going to hand it back to you because I'm going to go ahead and let you moderate questions.
All right, sure. Well, we have a few that came in already, and we again invite people to send in questions now if they would like to. But first of all, just from a general point of view, what are some of the common pitfalls that people run into when they're trying to leverage serverless systems?
I think, Chris, you covered a lot of that in your initial presentation. I mean, many of these pitfalls are going to come down to my code has expanded far beyond where it initially started, and now it's consuming far more resources, and it's just more expensive to run as a Lambda. I mean, from our perspective here at Instana and in the customers that I interact with on a day-to-day basis, that's the #1 reason they abandon Lambda to begin with, and they typically move off to something like Fargate or ECS that's more comprehensive for that use. On top of this, if you're somebody who doesn't want to be locked into a specific vendor, whenever you start utilizing serverless functions, you really are going down that path of saying AWS, Azure, Google, whoever you've selected is going to be your vendor of choice, because workloads like Lambda just cannot be shifted from one cloud to another very easily. You might own the code, but that code is still wrapped up in something that's designed to be run specifically inside of that cloud. So from my perspective, at least, that's what I see as those pitfalls.
Yeah, I think that's a good point. I will say that on top of that, something you have to be cognizant of, even with all those things work out okay for you, different pieces of code are going to operate at different levels of efficiency. So if you have a bigger function, all of a sudden you're not getting the same efficiency and you're not getting cost savings. Maybe you have one that, because of the state, you have to have on all the time, therefore you're not really saving anything. So it's not a one size fits all kind of concept, but even within your own code, it's not one size fits all.
That's a good point.
Gotcha. All right, so here's something that kind of dawned on me while you were talking. A lot of developers, as we know, a lot of new ideas and ways of doing things are brought into organizations by development teams looking for a better way to get things done. So are you finding when you talk to people that developers are kind of experimenting with serverless, but it isn't an organizational initiative, so there's some disconnect between the devs and maybe the IT people about, well, I've written this thing, well, now what do I do with it, and how do we monitor it, and things like that? Are you seeing that out there?
Oh, absolutely. I mean, the main thing that you see, and Chris kind of mentioned this in his initial part as well, is that you have a lot of developers who don't want to have to wait for IT ops or DevOps to spin up the infrastructure they need to run their tests. So a lot of times you find they'll just throw something into a Lambda if it's a little piece of code they're running for development. And then you run down this path of a developer who continuously develops that Lambda. So by the time you reach the end goal, you're now stuck having to run this as a Lambda function because that's really what it's designed to do. And then you have a bunch of IT ops guys going, well, then why did I just stand up this EKS cluster for you? We were going to run this as a container. Why are you changing this on me? It happens daily.
Mm-hmm.
Actually, it happens daily across all microservices. It's just exacerbated with the serverless. But what we're seeing, and we've seen this for a few years, and Dave, we started to see this even as we were starting to build Instana from the ground up. Developers are going to pick the best technology for them to do what they need to do. They're being given more responsibility. They're being given they're being given more accountability for their pieces. And if that's going to be the case, then they want more power in what platforms they write on, how they write it, what languages they use, et cetera. And this is just another example of that. And then you throw in, as Drew said, they don't want to wait for ops to come on. I had a customer a couple of years ago, not with Instana. It was an IT ops director, and he was having a conversation with the VP of engineering, and he said, "I don't understand why your guys are complaining. We have optimized. We have gotten our process down to 2 weeks from the time they submit the request for a server to the time that they get it." And he says, "Yeah, but they can take a credit card and go to a cloud vendor and have a Linux server spun up in 20 minutes." And that guy didn't sleep for a week because he was worried about what this meant for IT ops. And what it means for IT ops in reality is this shared environment space where IT ops has to work with the developers and understand this is the stuff they're developing in, so this is what you're going to be responsible for running.
Mm-hmm. Very good. All right, so one of our attendees wanted to know when you were talking about the possibility of vendor lock-in and working with that. So the question was really like, well, what about Knative, which is this open source platform for microservices management?
I was actually hoping you were going to bring that one up, Dave, because I caught that question from I believe it's Geoff down here in the chat.
Right.
And I was kind of poking around on Knative while Chris was giving his piece of the presentation. And yeah, from what I'm seeing in there, it is sort of a vendor-less serverless platform. It seems more like they're doing a managed Kubernetes where you provide them the container images and they just kind of take care of the rest for you, which is still wildly beneficial. I mean, this is kind of the same thing essentially that Fargate and ECS are doing, right? You provide them a container, they run it on top of Fargate EKS, and away you go. But with Knative, it does sound like from some of the things that they provide, since it's very simple, we're just provide me a container image. This does give you a bit more flexibility to be able to transition workloads from point to point, because you are now just using a Kubernetes native framework. So essentially you can just migrate your Docker container from point to point. So I do think bringing up Knative was a great point, and having looked at it, it is a lovely looking serverless platform that honestly, if you're interested in something that doesn't provide a large amount of vendor lock-in, is certainly something worth exploring.
Mm-hmm. And then is that something that they could use a solution like Instana with to add on to get the monitoring piece, where that's really kind of more of a management piece?
Well, with Instana, your difficulty here is going to be this is a managed Kubernetes system, right? And for us, because we don't have a requirement to stuff an agent inside of every container, we actually live at the cluster level as a daemon set. So this would present some challenges for the way in which we monitor things, because our layer approach with Lambda doesn't necessarily apply when all you're doing is providing a container image to Kubernetes. So while there are some options that we could provide, they're currently not provided out of the box today. So Knative would be a gap for us, unfortunately.
Gotcha. Very good. All right. Well, I'll invite our attendees. We're coming up towards the end of time, but we still have time for a question or two if you want to just fill one out and shoot it over to us. But in the meantime, so let me just ask you, Drew, back to you. When people are potentially considering adopting serverless technologies, what are some of the things they really should be taking into consideration?
Number one, top of the list, how much code are you trying to run in this thing? I mean, like I mentioned earlier, that is the main driver for people moving from Lambda to Fargate and potentially even going off to something like EKS and monitoring it themselves. Because the bigger your code base is, the more you're trying to run inside of a Lambda, the more expensive that's going to become. The second thing you definitely want to keep in mind here is how often is this Lambda going to be invoked? Because the more frequently the process has to run, the more the bill is going to rack up. These are really functions that are designed for, quick hit little jobs. In the context of my demo environment, for example, you may have seen that the service is called ratings reward, because the idea is we have a service called ratings, and if folks go in and they provide a rating to my shop, there may be a reward tied to their membership goal. But that's not something that's going to happen every single time they do a review. It's going to happen at certain staggered points. So that Lambda doesn't run every single time. And that's a good use case for it, because it's something that it's an ancillary process that doesn't happen every time. And the logic to do so is very, very small. So keep in mind of how big this thing is going to be running, or how much code is going to be running inside of this thing. How are you going to monitor it? Because as Chris said, if you're going down the path of like a Jaeger or a Zipkin that requires significant code modifications, you could be adding 10 to 20% additional CPU resources on top of that just by virtue of the additional instrumentation. That's part of why we use a layer with our lightweight auto tracers, is they limit the amount of interactions into the code to just what we need to do to trace it. And it doesn't add much to the code base, if anything. So when you're looking at serverless, the main thing you want to keep in mind is your bill, because that's the one spot that's going to come back to bite you in the tail really, really quick. And the things that drive that bill are going to be your code and invocations.
Chris, any final thoughts on that?
Drew nailed everything. I'll just point out the bill is kind of an important aspect. There's a nuance of software engineering that is engineering, and the more that we get the lines blur between development and operations, cost is a part of engineering. Of course, if you engineer big systems over the years, that is definitely something that you look at. But software engineers have been pretty immune to cost over the years, but now this comes right into the bailiwick. Why are you writing it as a serverless function? To save money. So if you're not saving money, you're not actually achieving your goal. I think one of the cool things is that there's opportunities to create extremely efficient, like I said, my hair literally didn't stand on my arm, because from what's possible to do with this, you can create some really awesome pieces of code that are very efficient cost-wise. But of course, there's also, with any cool new technology, the chance to do something that would kill you from a cost perspective too.
Great. All right, well, it looks like we're right up against time. So before we go, I would just like to thank Drew and Chris for a very informative presentation. Thank you very much, fellas. And certainly want to thank Instana for sponsoring today's webinar. And especially I'd like to thank the attendees who joined us from wherever they are in this crazy time and hanging in with us for the day. Appreciate your time. So until next time, I'm SD Times Editor-in-Chief Dave Rubenstein, and so long for now.
Thanks, Dave. Bye, everyone.
Take care, everybody.
I forgot Stan. Here he is.
Stan's awesome. Thanks.
Okay, thank you.